Welcome back. In this lecture, we're going to demonstrate how to load a CSV file into a Polars data frame. We've included a CSV file in the course materials for you to code along with us. If you haven't done so already, pause the video and download that resource now. Okay, now that you're ready, let's dive in. To open CSV files as Polars data frames, we'll be using a function called readCSV. This function comes with a number of arguments that you can pass to change how the CSV is opened. We're going to keep our first example simple and use the default arguments. First, we'll start by importing Polars as PL. Next, we'll define a new variable called data and set it equal to pl.readCSV. Within the functions, we'll type the path to our CSV file. The CSV file that we'll utilize in this demonstration is the employees CSV file. Now that we've defined our new data variable, we want to display our data frame. In Jupyter Notebooks, you can do that by simply typing the variable name. To display just a few rows, we'll call the head function off of the data frame variable. When we run the cell, we get our Polars data frame displayed in a nice tabular format. We also get the shape of our data frame in a tuple format that tells us how many rows and columns there are. Here it's just counting the rows that contain data. The first two non-data rows in the data frame contain the column names and the Polars data type. Pretty simple, right? The readCSV function makes it easy for us to quickly create data frames. That said, we have really only scratched the surface on this function's capabilities. Let's review a few additional arguments now. As a data engineer, you're bound to work with CSV files that both do and don't have column headers in the first row. By default, Polars assumes that headers exist. However, you can tell Polars that the first row of data does not contain column headers using the hasHeaders argument. Let's do that now by once again opening our employees CSV file. This time, we'll call the hasHeaders argument and set it equal to false. Let's display the first few rows of our data frame by calling the head function. When we run the code, we instantly see that something is wrong. The column headers are now in the first row of the data, and the column names are now generic. This ultimately isn't what we want for this data set, but it does illustrate how we can adjust our Polars data frame for CSV files without headers. A somewhat related argument is called newColumns. This allows us to overwrite our column headers by passing a list of column names. If you're working with files without column headers, this is a perfect way to add them in for greater clarity. Let's demonstrate how this is done. First, we'll create our list of headers. We'll put this list into a new variable called column names. Once you have that list, we'll go ahead and reuse the same code as before, copying the hasHeader argument. We'll then call the new columns argument and pass our column names list. Let's once again display the first 5 rows of the output. Now, instead of having column 1, column 2, and so on, we have our new column names. In addition to being able to change the column names for files without column headers, you can also use this function to change the headers on a file with column headers. Let's quickly show you how this is done. We'll once again reuse most of the same code as before, but this time we'll drop the hasHeaders argument so that Polars assumes we have column headers in the first row of the file. We'll use the same column list that we defined above and then run the code. Once again, the column headers were rewritten in our data frame and now look nice and clean. Let's take a look at some more arguments. Believe it or not all CSV files are comma separated. I'll say that one more time. Not all CSV files are comma separated. As a matter of fact, you can use any delimiter you'd like within certain limits. Some of the most popular separators are semicolons, tabs, and pipes. Let's get some practice with this by opening a tab-separated file. We included an employees tab-separated file in the course resources. If you need to, go back and download that resource now. To open this file, we'll once again call the readCSV function. This time, we'll be opening the employees TSV file. By default, Polars assumes the separator is a comma. If we were to run the code as it is, Polars would fail to parse the data correctly. Let's demonstrate this by displaying our data frame. As you can see, all of our data is in the same column. To fix this, we'll call the separator argument and pass \t. Now that we've declared our tab separator, let's try displaying this data once more. When we run the code, we get the data frame that we'd expect. Next, let's review the data types argument. By default, pullers will try to pick the best data type for any given column. While it does a pretty good job at interpreting the data, it doesn't always hit the mark and give us the data type that we really want to work with. For example, our salary column was read in as an integer 64. This works with this data set because there are no decimal values, but let's say that I actually want to represent this data as a float. To do this, I can use the data types argument. Once again, we'll call the readCSV function and pass the file path to our CSV. Next, we'll call the dtypes argument and pass a dictionary of the columns we want to change with their respective data types. In our case, we want to change our salary column to be a float. We can do this by typing pl.float64. When we display the data frame, our salary column is no longer sporting an integer 64 value. Instead, we now have it displaying as a float value with decimals. You might have noticed that we have a date of birth column, but the data type currently in use is a string. While this might be fine in some circumstances, there will be times when you'll want to read date columns in with actual date or datetime data types. To do this, we can use the try parseDates argument. This will essentially tell pullers to look through the CSV file, identify date and datetime patterns, and read them in as a date or datetime data type. Let's demonstrate this with our employees dataset. We'll once again call the readCSV function and pass the file path to our employees CSV file. Next, we'll set try parseDates equal to true. When we run the code, we get back our data frame once more. This time, instead of a string data type in the date of birth column, we have the correct date data type. Okay, that's all we have for this video. Coming up, we'll walk through how to export pullers' data frames back to CSV files. We'll see you there.